Okay, so today we're going to be talking about using law of signs on the ambiguous case. So let's recall back to geometry. Back when you did proofs in geometry about triangles, there were certain acronyms you could use to show that two triangles were congruent to each other. The most the first one you did, the most comprehensive way that you showed that two triangles were congruent would be that you looked at two triangles and you proved that all the corresponding sides and all the corresponding angles were in fact congruent to each other. Okay, so these top ones were congruent to each other, and then the side ones. Well, that was only one day of it that you did all the sides and all the angles correspondingly were congruent. Then you learned acronyms were like, you know what? If the all three sides were correspondingly congruent to each other, well, then guess what? Their angles will be congruent as well. So side, side, side was a proof. Side was a proof. Angle, side, angle, hypotenuse, leg. Those were the ones that you could show, hey, guess what? If I have the matching um, angle, side angle, to be congruent between two triangles, because the measure of an angle directly impacts the length of side across it. And if you know two angles, well, the third angle will be congruent. Then you absolutely, if you had side, angle, side, 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 well, if those corresponding parts were congruent between two triangles, those two triangles would be congruent to each other. The one that you were not allowed to use was angle, side. And when it's in print, we normally do side, side, angle. And that means you know two sides in a row match each other in two triangles. And then an angle either before or after that. Okay, again, when you did proofs, you talked about an angle and then two sides that followed. If the angle was in between the two sides, we would call it side angle side, and that was a valid proof. Okay, if the angle you know is either before the two sides or after the two sides, then it would be angle side side. Another way to talk about this is if you had side angle side, notice there is no common pairing of an angle and the related side across from it. Okay, so in angle side side, you're going to be able to use the law of sines. And that's another way to kind of differentiate. Side angle side, you've got to use the law of cosines. So, which is in the next unit, but you did learn that last year in honors geometry. If you had regular geometry, then this chapter is pretty much new to you. And feel free to reach out for help as you need it. And so the thing is, angle side side is not a proof, and it's not just because it spells a bad word and we want to keep kids from saying bad words. It's because if you've got angle side side, sometimes there are two different triangles that you can form with those dimensions. Okay. And so you're like, well, that's just weird. And so a proof says if you have these three dimensions, well, then any triangle you draw with those dimensions will match any other triangle that you would draw with those same exact dimensions. You're like, well, you're becoming very confusing at this point. And the answer is absolutely I am. Well, the plot thickens, it gets worse. With this angle side, they actually may give you three dimensions that can't even form a triangle. I don't know why, but they decide that's a cool move to do. And so I'll show you kind of a situation for that. So say that, for example, you've got an angle. Okay, that's 30 degrees. Okay, say that's angle A. And say that this side here is, say, 10. Okay. Can you imagine that they could give you the side A to be 1? And do you see how that there's no way with a 30-degree angle and a length of 10 that this length of 1 will ever connect with that bottom triangle. And so the way that that would manifest itself would be, even if you do it like this, you're like, oh, it's 1. The first angle you would try to find would be this angle here. And so if you did the law of sines with this triangle, say we call this side B, we call this angle B. You would be like the sine of A over the length of side A, which is 1, would equal the sine of B over 10. So I would cross multiply and solve, and I would get 10 sine of A equals the sine of B. And to get angle B by itself, you're going to do the inverse sine of both sides. And that would mean that the measure of angle B would be that answer in your calculator. So if I take out my calculator, I go second sine. Oh, my calculator's being precious. Second sine. Come on. Oh, it did it twice. Cute. Okay, so second sine. And then I do 10 sine. Oh, and A is 30 degrees. I don't know why I didn't put 30 degrees here. Okay, of 30. It's going to give us an error. Okay, so if you have angle side side and you get an error when you're trying to find your first angle, it is likely that they gave you an impossible triangle, something that you cannot form a triangle with those dimensions. And let me show you, we have a modeling figure about this because this is kind of hard sometimes for kids to get. They're like, if you have an angle and the side across from it is too short to form a triangle, you could have no triangles that are doing it. You're like, why is this thing spinning? Or is this going through space? Okay, I'm trying to think of it. Why is this swinging back and forth? That'd be a better word. And the answer is because they're trying to say, no matter the angle you form with that dimension, the deal is that you can't form a triangle. So if we had something like we talked about before, where this is 10, I can type this in. I'm not sure I can type. Let's say 10. So the picture that I drew, and then if this length was, say, indeed 1, or the 30 degree, notice you can't form a triangle with that. Okay, there is no way to form a triangle with those dimensions. Shut this a little bit. Because that second side is too short. Okay, and so they find it funny to give you 3 dimensions, an angle, and then 2 sides that follow it, so that when you do law of sines, you get an error because it's an impossible triangle. It gets worse. Okay, so if you get an error, look at it. It probably is because it's not a triangle that you can solve. Okay, so the next thing that they're going to possibly think to do is that you have just one triangle that you can draw. And so I can show you, that's kind of like this one right here, where you can just literally form one triangle. And if you increase it just enough, I don't want to increase that. If you increase it just like, so it's the shortest possible length. So it could form one triangle. I'm suffering this here. You type in like 5.5. 5.4 looks like just the shortest length it can be, where it's long enough to connect. If I did 5.3, it would be too short. It wouldn't connect. Okay. So there is a happy medium where like that next side has to be just long enough so you can form a triangle. Okay. So then they find it funny, be like, I could give you dimensions that you could actually draw 2 triangles about. And one is more of a narrow triangle, okay, like this one right here. Okay, so if you have a length of A, you could put A as a tight squeeze and make a triangle with the angle of A, the length of B, the side of A. So it's a really narrow triangle. Or you could draw the A, so it's kind of more fat. With those 3 dimensions, you could perhaps draw 2 different triangles that one is more narrow with that length of A and one is more wide with those same dimensions. So there could be 2 triangles. And the rule is it has to be long enough to meet, but it can't be longer than this side right here. Okay, so if you make the length of A, the side across from angle A, just too long, it can only form a triangle by staying out here. There's no way to take that length and bring it at the same length in here and retain the same angle of A. Okay, you see how that A would have to be bigger in order to have the side A to form both a narrow triangle with that dimension as well as a longer triangle with that dimension. So the deal is that we have to say, well, can you even form a triangle? Is it long enough, that side A? Is it long enough to form two different triangles, or is it so long that it actually can form just one bigger triangle? And so, um, here's my analogy. So if you hate my analogies, just plug your ears. Okay. But the deal is that this is like the roof of your house here. Okay, and so some pets, like a puppy, you can have inside or outside. You can bring it in or you can bring it out. You can have your inside and outside pet. If your bee, like the roof of your house, this length here, is of a certain length, okay? If you have a certain size house, if you have too long or too big of a pet, like say you win a pet elephant at the fair, you cannot bring that inside. It will break your house, okay? It won't fit through the doors. You cannot retain your current structure with the dimensions of bringing that inside is out. It's got to stay outside the triangle. And so just stay as a wide triangle rather than a narrow and a wide triangle. Um, if your angle that they gave you is obtuse, there's just one triangle you could make if it forms a triangle at all. Um, and then if A is a right triangle and if A is less than B, then you have no triangle. I'm basically, if you get an error, you're going to say there's no triangle formed. Okay, so that's kind of the story. Um, the main things you're going to talk about is there no triangle? Is there one triangle? Or are there, and that would be in these two right here, when the length of A is so long that it can't go two different directions. Or there are two triangles, and then you actually have to find all three dimensions for the two different triangles that can be formed. You're like, that is weird. And let me show you the animations of this. Okay, so we said it could be too short, and how that would manifest itself when you're trying to solve the law of sines is you get an error for that angle because there's no triangle that can be formed. The length of the side across from the given angle is too short to actually connect and form any triangle. Now, if I increase the length of the side that's across from A, so let's see if this is it. If I make this like 5.4, it may, oh, I push enter. It may just form one triangle. Okay. And I'll tell you how to know, like, is it going to form one or two or none? So none is an error. We'll talk about how to tell if it's one or two. If I make it just a skosh bigger, like, let's make it 6. Notice you could have that second side. Okay. So angle side, the second side, the side across from the angle that you know, form a more narrow triangle or a wider triangle. So there's two triangles that can be formed with dimensions of an angle 30 degrees. A side across from it 6, side A is 6, and then that side is going to be 10.6. Notice your angle, the roof of your house, the roof line of your house is 10.8. The length of the side across from the angle that you know is going to be shorter than that B. So it's kind of like an indoor and outdoor pet. Okay. If I increase the length of that side to be longer than that roof line, which is our 10.8. Okay, say I make it 11. Notice if I try to bring it inside, okay, it's not the most noticeable, but if I try to bring it inside, like so I'll make it 13, okay? But even if it's just a little bit bigger, notice you cannot fit that side length inside and outside because notice it kind of breaks the triangle. It's like an elephant you're trying to bring in your house, okay? So the deal is that you got to kind of watch your dimensions, and I'll also teach you a couple ways to notice how many triangles could you form by kind of doing the math of the law of sines, etc. Okay, and so there's a couple ways. One is just kind of noticing, is the length of the side um, going to be longer than the roof? Okay, the length of the side that doesn't have a pairing, or is it going to be shorter than that? Okay, so again, if it equals it, 10.8. If it equals it, it has to be, oopsie, let me push enter. If it equals it, there's just one triangle formed. Okay. If it is a little shorter than it, 10.2, enter. You could form a real narrow triangle or a wide triangle with those dimensions, okay? So you just watch and say, is it long enough that it can connect, but then also form two triangles? Or is it too long where it has to basically, it's too long to form just, make it more obvious. I'll make it 14. Notice with 14, it has to stay outside. Otherwise, it can't form a more narrow triangle. Okay, so let's go to our actual problems that you would see. Okay, now notice I see two sides and an angle. How do you know if it spells angle side side or just side angle side? Okay, because they're the same letters, the order matters. The way that you know is if two sides and an angle, okay, is there a pairing? What do you mean a pairing? An angle and side that match, that go together. So like in this one, we have angle side A and angle A. Okay. Then check if two triangles. Okay. If it was two sides, I don't know why this isn't writing for me. Awesome. Okay, great. Maybe it's lagging. Okay. If, well, it's not writing. Okay. If it has two sides of an angle and not a pairing, you'd have side angle side. So if you knew angle A and you knew side B and side C, but you didn't know side A, okay, then you could not say this was 8 and say this was like 10, say this was like 40 degrees. If you don't have a pairing, well, then you can't do the law of sines. You know side angle side. You would use the law of cosines, which we'll learn on Monday, okay, or the next day that I meet with you guys. And so, and if you learned it last year. So let's look at this. We know angle A, and I always suggest you put the angle you know in your left hand and the side that you know that pairs with it across from it, okay? And so side A equals 50, okay? And then, so those pair up together, okay? So angle A, and let's put that in there, and side A is 50, okay? A is 28 degrees. And so we've got the law of sines. We can do sine of 28 goes with 50 equals. And then I tend to put the other side, just in on the left side, okay, between the angle and the side So this is side B. B equals 20. Now notice, if I drew this to scale, the length of side A is pretty long, okay? And so if I drew it more to scale, it would look like this. Maybe 50, it's quite a bit longer. Okay, so if this is 50. And so if we do the law of sines for this, we would say sine of 28 over 50 equals, and then if I know side B, then this must be angle B over here. Okay, so let's put this here. So we do sine of B goes with 20. And so if we cross multiply and solve, we would get 20. That would be 20. And divide both sides by 50. And then we're going to do the inverse sine of both sides. So if I put that in my calculator, I'm going to get the measure of angle B equals 10.82 degrees. Okay. And so we could put this down here, 10.82 degrees. Now I know in the prior chapter, I'm like, don't only use given data. In this chapter, we do law of sines and cosines. There are times where you actually have to use data that you found throughout the question. That's just the only way that you can do it. And so the thing is that notice 50 is too long to be brought in to form another triangle. It just is, okay? And so The way that you could check it is this. If there was a second triangle, what you do is if this is B number one, okay? So the first angle you find, you can call it whatever letter you're supposed to. Maybe it's B1, maybe it's C or D or whatever it is. But to find B2, you would equal 180 minus B1. Why would we do that? Well, how you would do that would be if you drew this, and I wish I would not have drawn this to scale. I'll just draw it down here, not to scale, so you can kind of see what I'm doing. So say that you had your angle A, and say this was 28 degrees, and if this was, I'll call it 11 degrees just for, ease right this second, so we can talk, logically. So this is not that one, 28 degrees here. If this was 11 degrees, again, I'm rounding just for your brain. And since this side was 50, we're checking to see, could this be brought inside where these two are congruent? Okay, there would be a more narrow triangle you could form here. Oops, I wanted to highlight it. Where the more narrow triangle here, where this would be the same 3 dimensions, okay? The side here would still be 20, and the side here would be brought in or out and form 2 different triangles. A more narrow one that would be kind of hugging inside, or that this would stay outside like this. And so how you find if there is a second triangle, first of all, we know there's not because 50 is longer than 20. It would break the house. It's an elephant. It doesn't fit in there. And even if you try to draw here, you can't retain angle that's 28 degrees and have that come inside. Now, on the other hand, if you're like, I still don't know what you're talking about, let's just do some math here to say, okay, how could we figure that out? To find, if you know this angle B, B number 1 is 11 degrees, remember your world of geometry. If we focus on this triangle here, and again, this triangle right here is not one of the 2 triangles you could form, okay? This is just kind of a prop. And so if you have an isosceles triangle, you remember from geometry world that if the 2 sides match, their angles, the base angles would also match as well. Okay, so whatever you find for B1, you would put this here and then define the measure of B number 2, okay, which would be the angle formed by at B for a slimmer triangle. Okay, so if you could form a slimmer triangle with those dimensions, angle B number 2 would be the supplement of angle B1. Okay, and so to find this angle right here, you would do 180 minus B1 or 180 minus 10.82. And so the measure of angle B2 is equal to, get my calculator out, 180 minus 10.82 gives us 169.18. And you're like, great, I got an answer. Great, there's probably a second triangle if you're running down that path. Well, then that means that you've got to find the measure of angle C. Well, where's angle C? Well, angle C on the bigger triangle, okay, the more obtuse one, is going to be found by subtracting the 2 angles, the measure of angle A, which is 28 degrees, and the measure of angle B1, both of those from 180. Okay, so the measure of angle C here is 180 minus 28 minus 10.82. And that would be 141.18 degrees, okay? So this is going to be fine. The problem that occurs here is that if you're focusing on this more narrow triangle that could be formed, the measure of angle A stays the same as 28 degrees. But if the measure of angle A is 28 degrees and this is 169.16, if you do 180 minus 28 minus 169.18, the problem is the measure of angle C equals negative 17.18 degrees. That tells you, no, you can't form 2 different triangles with the given dimensions, okay? So you would solve with law of sines to find that first angle, okay? To try to see if there's a second triangle, you can either notice, hey, this is too big to form 2 triangles, or you can just say, well, to find the secondary option for that triangle angle I just found, a more narrow option, you take 180 degrees minus B1, that'll help you find the more narrow angle B. Okay. And then you have to start to say, is it possible to find this part C? Okay. And if you get a negative answer, you're like, no, there is not a second triangle. There's only going to be one. Okay. So if there at this point, we just focus on solving the larger option, the first initial and single triangle that there is. And so the only other side we have to find is side C. Okay, so to find C, we're going to say the sine. Okay, why is this not working? Well, there we go. It's crashing. Okay, we would say the sine, I'll not tell you. Straight. Okay, so um, I think I've got a patch here. So we could do sine of 28 goes with 50 equals, we want to find if the value of C is going to be 141.18. And notice that's pretty obtuse, and that makes sense. If these two sides are very big, that angle's got to be pretty big, to keep that accommodate the length of 50. Okay, and so we're going to do sine of C over length of side C. Huge. And so if we cross multiply and solve this, we're going to get C sine of 28 equals 50 sine 141.18. Divide both sides by sine of 28. What I would do is I would take out my calc and I would put that as a fraction key, okay? And then I would get the length of side C to be 66.76. And that would be, it looks like it's units. So anytime you know two sides at an angle, and the angle has a pairing with that side across from it, like it's angle A and side A across from it, or angle C and side C, you've got to check to say, first of all, do you get an error? Is there no triangle? Secondly, when you find your first angle, are there two ways to put that within your triangle? Is there a narrow and a wide way? And how you can do it is either kind of noticing patterns, saying, is it bigger than the non-matching side? Okay, the side that doesn't have an angle across from it that you know. And or you can do the subtraction to say, take your first angle, subtract from 180, assume you could do that angle, take the given angle here, do some math to figure out what would that third angle be. And if it's not possible, you'll get a negative for that value. If it is possible, you actually have to solve both of the triangles, the narrow one and the bigger one. And so you would just do the law of sines again on the more narrow triangle and using that smaller c that you would find here. And I'll demonstrate that in a moment. And so let me minimize this and go back to our examples here. So example 2, find the number of triangles that can be formed with these. And so I always say, okay, you got two sides and an angle. And notice we do have a pairing. We have a side with a related angle, so we can do the law of sines. That means it is angle side side. Okay, two sides and angle. Again, if we didn't have a pairing, like it was angle A, side C, side B, again, nobody matches, you would do law of cosines, which you haven't learned yet, okay, unless you remember it from last year. So this right here says, given an angle of 105, and the thing is this kind of goes to our examples up here. If the angle they give you for angle side side is obtuse, as long as it forms a triangle, it's only going to be one. Okay, so there's not going to be two different options for it. So let's just check and see, can we form a triangle with it? Because that angle they gave us is obtuse, if you could make one, there will be only one. So this is angle C. The side across from it is going to be side C, which equals 10. And the side we know, I always put between them, this is side B, which is 6. And so the pairing we know is this angle goes with this side here. And so we could do sine of 105 goes with 10. And then we know side B. So we're going to say the sine of B goes with the length of side B, which is 6. So let's do 6 sine of 105 equals 10 sine of B. Divide both sides by 10. And then to get rid of the word sine, you're going to do the inverse sine of both sides. And so the measure of angle B will equal basically the side of the equation. And so I can take out my calculator if I still have it open. Second quit. Okay, we're going to do second sine. I'm going to do alpha y equals enter. On the numerator, we're going to do 6 sine of 105. On the denominator, we're going to put 10. And let's see what we get here. We get 35. So we get 35.4. I said round to the hundreds, so 0.42. Okay. Okay. So we know that the measure of angle A equals, actually C, is equal to 105. And then if you feel not so smart, okay, and you're like, I think I want to see if there's two triangles. Here's what you would do, okay? You would say, define the measure, that would be number 1, okay? This is B. Define the measure of angle B2. You could do 180 minus B1. Okay, so if you did 180 minus 35.42, and we'll just do it just to, kind of go through the motions of you, because sometimes you feel like, oh, I understand. I don't need to show my, to try for two triangles because I can tell there won't be one. Other times you're like, I just don't feel so smart. So this would be the measure of B2 would be that. So A is angle C stays the same. The given values stay the same. So angle C equals 105. Got a question. Do you see a problem with finding even another angle with this? Okay. If you did 180 minus 144.58 minus 105, guess what? Measure of angle C would have to be negative 69.58. You're like, that's a problem. Okay, so basically, if you have angle side side and you're given angles up to, you're only going to have one angle, one triangle formed. And so this B is going to be 35.42. And then we've got to find angle C. And you get that by doing 180 minus the two angles you know. So 180 minus 105 and also minus 35.42. You get 35.58. Excuse me. Okay. And then we have to find, so that would be up here, 35.58. And this is angle A. I'm not sure why I put C. Let's call it A. She's A. All right. And we have to find the length of side A across from it. And so we'll do the law of sine. So sine of 105 goes with 10. That's a given pairing. Equals the sine of a 35.58 goes with the length of side A. And if you cross multiply and solve this, I can show my steps up here if you need to see it. You would get A sine of 105 equals 10 sine 35.58. To get A by itself, we're going to divide both sides by sine of 105. I need to clear my throat. All right, and if you find that quotient, use the fraction key in your calculator. You're going to get the length of side A to equal 6.60, and that'd be units. Alrighty. So I would ask, is there any questions? But you certainly can pause the video and talk to your sub or ask me if you want to. The next thing would be, let's try this next one. This next one's going to have two triangles. And let's see if we can figure out, see the clues, see if we can kind of practice walking through this because you may have questions about it. So again, we've got two sides and an angle. How do you know it's not side angle side? It's because you've got a pairing. What do you mean? Well, put the angle in your left hand. Okay. If you saw me, you'd be like, okay, hold up your hands, and put it in your left hand. If you hold your hands in front of you, face palms down. And so angle A is 39 degrees and side A is across from it. Okay. That's 14. And then another side. I put it on my left hand. I put it right here between the angle and the side So this is side C equals 20. Okay. Now notice, if you actually were going to do this, you would notice you could swing the 14 either in or out. And if we had that animation still going, I closed it, you could make this 14. It's small enough, it's like a puppy. It can be out or in. You can form a big triangle where it's more of an obtuse angle at the top, or a more narrow triangle where it's swung in. Okay, because 14 is short enough to be out or in. Okay, and so there's a bigger triangle formed like in the wider variety, and then there's a smaller triangle formed if you keep it in the more narrow situation here. Okay, so why? Because the length of the side across from the angle is smaller than the roof or the other side. Okay, and so let's take this here and let's solve our triangles. Okay, and some of you guys are like, I don't know if I can envision this. Okay, well, that's fine. We've got let's do the law of signs to find the first angle. So the first angle we're going to find is going to be named C. Okay. Sometimes it's called B, sometimes it's D or C or, whatever, but it matches with the given side that doesn't have a pairing. So we're going to do sine of 39 goes with 14 equals the sine of C over 20. We're going to cross multiply and solve it. Get 20 sine of 39 equals 14 sine of C. Divide both sides by 14. And to get C by itself, you're going to do inverse sine. Okay, so the measure of angle C should equal, I'm going to copy my work from here, should be 64.03. Now, the given angle, is 39. So that she does not change, okay? So the measure of angle A equals 39 degrees. That stays the same, and whether you form two triangles or not out of the given information. The thing that might change would be that third angle. So the measure of angle B now. To find this in the bigger triangle, you're going to subtract the two angles that we found in the bigger triangle from 180. So it'd be 180 minus 39 and 64.03. So 180 minus 39 minus 64.03, and that gives us 76.97. Okay. And then we will end up finding the length of side B as well. Okay, using those log signs. So we could do sine of B over, actually lies, sine of 76.97 goes with the length of side B, okay, equals the sine of 39 and 14. And if you cross multiply and solve that, you're going to get the length of side B to be 21.67. So that's the first triangle. Okay. The second triangle formed, okay, would be the same given dimensions. What are the given dimensions? This side is 14, this side is 20, and this angle is 39 degrees. Okay, those are the given dimensions. But what we're going to try is, can you take that side that's across from the angle, and can it go out and in? Can it form a more narrow triangle? And so I'm going to take this, and I'm going to say, let's try to swing this in to make a more narrow triangle here that's still 14 long. And how you actually do it is you remember that this is an isosceles triangle. The base angles will be congruent. Okay, so if you found this angle to be angle C to be 64.03, this would be 64.03. And to find the supplement of that angle will be our other angle, C number 2, to form this more narrow version of the given information. Okay. And that's the weird thing. It's an ambiguous case because sometimes the dimensions, can be forming two different triangles with the exact same original given dimensions. Okay, so we're going to just find the measure of angle. Again, the angle we found first was C. Okay, so to find the measure of angle C2, that equals 180 minus C1. So 180 minus 64.03. the measure of angle C2 equals 115.97. Okay, so what we do then is we say measure of angle A is the same still, because that was given, 39 degrees. C number 2 is 115, and let's see what B number 2 is going to be. Okay, so on this more narrow triangle, where would B number 2 be? Again, it's the more narrow triangle. It's at B. It would be up here at the top. Okay, the bigger triangle had a big B. Okay, the smaller, more narrow one of these would have a smaller B. And so let's check and see if there's enough degrees to make it happen. Okay, if there is room to have two different triangles formed, you take your original angle, your newly found angle, the supplement of it, and then you say 180 minus both to say, is there enough degrees in our secondary triangle to not go negative? So let's do 180 minus 39 minus 115.97, and you get 25.03. So it's small, but it's still positive. And so we can make two triangles. Okay, so two triangles on this one. And so in this more narrow triangle, we were given angle A, we were given side A, we were given side B, we found angle B up. Oh, we found C2. Okay. C number 2 is going to be 115. Notice it's up 2. It's down here at the bottom. And then angle B number 2 is up here. That's enough space for it. We just have to find the link down here at the bottom to find side B. B number 2. And so to do it, you're going to do the law of sines. We're going to say the sine of 39 degrees goes with the length of 14. Again, that was given. I'm going to grab a marker and see if I can highlight that for you guys to see it. All right, here we go. They gave us 39, and we know that goes with 14. And then we're going to do this equals the sine of B, 2, which is going to be 25.03 over that bottom little segment B down here at the bottom. And if we cross multiply and solve it, we're going to get the link to B. B equals 9.41. Now notice, it's 9.41. The other one, the bigger triangle, B is going to be 21.67. So the original values are the same, but with those given values, you can form a bigger triangle, and you find the missing angles and sides of those, which will be, you'll have to find two angles and a side. And then on the more narrow one, again, you're going to find the other two missing angles and the missing side on that narrow version of the triangle. So I'm going to have you guys in a minute. The next one is kind of cute. Okay, we like this one. And when I say cute, I mean it's going to turn out nice. They give us an angle A is 73 degrees. Put it in your left hand, okay? If your palms are down, your left hand, put your angle there, put the side across from it that you can, okay? Side across from it is going to be side, that's 12 units, and that's A. And then length of B, okay, the other side is going to be 17. And we're going to look for angle B. So because we know two sides in an angle and we have a pairing, we're going to have to look for, is there even a triangle? Are there two triangles, or is there just one? Now notice, this one here appears that it could go out or in. 12 is shorter than 17, okay? Kind of would be like a puppy where you can swing it in or out, okay? Not like an elephant where he has to stay outside in the backyard, okay? So if you win a cow or a elephant at the fair, you better leave it outside. So if this length was like 25, it would have to stay out here. There is no way you could bring it inside as well. That was quite clever how it turned into a straight line itself. Okay, let's see if I can get rid of it now. Okay, so let's do the law of sine. So like sine of 73 goes with 12, just like the sine of the angle we're looking for, it's called B in this case, is going to go with 17. So let's cross multiply and solve. We're going to get 17 sine of 73 equals 12 sine of B. Divide both sides by 12. And then to get rid of the word sine, you're going to do inverse sine. If you put that in a calculator, you're going to get error. What does that mean? The 12 is too short. Okay, if you drew it to scale, you would notice this was 17, this was 73 degrees, and this 12 would not connect. It'd be just swinging free in the breeze. It's not going to actually connect. There is no triangle. Okay. If you got an answer, well, then you would look to say, are there two triangles or is there just one? Okay. In this case, there is no triangle formed because that second side is going to be too small. Okay, this last one is going to make two triangles. And so I would say pause the video and try it and see if can you actually do this yourself. How do you know that there's a pairing? I see angle A and side A, and I see additional sides. So I've got an angle and two sides, and one of the angle and the side are the same letter. Okay, so put the letter you know in your left hand. And the side across from it is side that's 11. Okay. And the side that this, I'm going to make this just guess. Let's make the 17 a little longer than the 11. Let's also make it more like a 30-degree angle. Okay. Okay, so if this is 17, now you don't have to draw them to scale. I'm just trying to make your brain identify with this. This is going to be able to probably be drawn in or out, okay, as a wider triangle or a more narrow, slimmer triangle. How do I know? I have the answer sitting next to me. Okay, that's how. So this side right here is 11. And so how would you know? Well, notice the 11 is shorter than 17. Okay, we know where they need to be placed because A and A are across from each other, and B, they give us is across from B. And so I would always put the second side, in between the given angle and side, if it's angle side side. And so we're going to do law of sines to solve and be like, hey, let's find angle B. So sine of 30 equals, okay, over 11 equals the sine, and that it must be angle B equal over 17. If we cross multiply, 17 sine of 30 equals 11 sine of B, divide by 11. To get B by itself, we're going to do inverse sine of both sides. So the measure of angle B, B number 1, okay, is going to equal 50.6 degrees. Okay, angle A equals 30 degrees is still, and we can find angle C in a second. We're going to quickly run up here and say, is there a second triangle? How do you do it? Well, if you were to swing this in, to make a more narrow triangle, the 11 would be the same length, okay? So that's the question is, can you use the 30 degrees, the 17, and the 11 to form a fat triangle and a more narrow one? Does it actually work numerically? And so we found this angle down here to be 50.6 degrees. That means this will be 50.6 because of isosceles. Again, the triangle that's here is not really an answer. This is just a prop to help us find the bigger and the more narrow triangle. So some kids get confused and like, I see three triangles. I'm like, yes, you do. But we're trying to say using the given 30 degrees and the 17. That triangle doesn't use the 30 or the 17. So, okay, so let's go back to here. So if this is 50.6, to find this other angle B, number 2, which is over here on the more narrow triangle right here, we're going to say, is it possible to form a triangle there? So how you find it is you go the measure of angle. Let's see, we first found B1. Okay, so let's find B2 equals the supplement of that first angle we found, 180 minus B1. So 180 minus 50.6. And if you subtract those, you're going to get 129.4. Okay, so it seems promising. Let's do this. So measure of angle A. Okay, so we're saying, is this more narrow triangle possible? And you won't know that until you try to find this angle up here. Okay, this is C number 2. So C2 would be the smaller one. C, the bigger one would be C number 1. So C2. So measure of angle A retains its 30-degree size. And then the measure of angle, let's see, number 2, okay. Measure of angle C. Okay. Would equal 180 minus those two angles. So 180 minus 30 minus 129.4, and we get 20.6 degrees. Oh, it's not negative. So guess what? You can form a more narrow triangle. The second one you find is the more narrow triangle. And so you could use the law of sines to find this bottom side C of the more narrow triangle. So you'd say sine of 30 over 11. Again, that's the green part. 30 goes with 11 in both triangles equals the sine of 20.6. That's this one up here over C. And if you cross multiply and solve that, we're going to get C, number 2, the length of side C2 equals 7.74. So because we can do all three angles a more narrow way, okay, the yellow triangle actually works. If you go back to the very bigger triangle here, excuse me, we have angle A stays the same. Angle B is the one over here, okay. Need to get a charger. My computer's about to die. Okay, so they got us over here. And then we're going to do, I'm going to pause a second and go get my charger. Okay, back to us. So in the bigger triangle, we still, again, it's a little bit weird to see, but you've got the given angle here is 30. We have the given side over here. We found this first angle there. And then, well, that was our fireplace. And then we found the angle. Oh, we got to find the angle at the top. Okay, so 180 minus those two angles is going to give us 99.4 degrees. So in the bigger triangle, those are our angles. And then we have to find the length of this bottom C. So we're going to find C equals, we'll find that in a second. So we're going to do sine of 30 goes with 11. And then sine of the big top angle up here, which is going to be 99.4 degrees over the length of side C. If we cross multiply and solve, we're going to get 21.7. And that would be units. So I think the big thing is, can you see that sometimes if I'm given an angle side, you can draw two triangles with those dimensions. And the main thing is that side that's across from the angle small enough to go in and out? And if it is, then you can make a wider triangle or a more narrow triangle with those dimensions. And the hinge point, okay, is going to be to take the first angle you find right here. That's clear as mud. Not helping. To take that first angle here that you find and say, if this angle right here is 50.6 degrees, can you take 180 minus it and then say with the given first angle they gave you and the angle, the supplement of the angle you found, is there enough degrees to have a positive third angle? Okay, can you form a smaller angle here, triangle here, or does it just need to stay outside? And so you walk through finding that bottom side of the narrow way and the wide way, and that's the very bottom answer. And that's about it. So practice it and let me know if you got questions. Thank you so much. I hope you have a great day.